Alright, we're going to take a look at applying the properties of operations to multiply and divide rational numbers. So in your journal, how can we evaluate the expression below? Will different strategies result in different answers? Why or why not? So go ahead and copy this evaluation, or this expression. So for example 1 on your worksheet, using the commutative and associative properties to efficiently multiply rational numbers, evaluate the expression below. Well, starting off with the negative 6 times 2 times negative 2 times negative 5 times negative 3, we would start with the first, moving left to right, since this is all multiplication, we would start with the first 2. So that would become negative 12. And we copy down the rest of the expression since we haven't modified that or manipulated it yet. Then we take the next two terms and multiply that to get 24. And the next two terms, and then the last two terms. So what we end up with is 360. Another way to do this is by using the associative property of multiplication, multiplying the two numbers that are negative, because 10 is an easy number to multiply by. Then we can switch the placement of 10 and negative 3 by using the commutative property. And then multiplying the 2 and the 3, we would get negative 6. So now we have negative 6 times negative 6 times 10. And then because we know negative 6 times negative 6 is 36, and last but not least, multiplying the last two to get 360. So what types of strategies were used to evaluate the expression? Well, the first one was the order of operations, rearranging the terms in the commutative property and multiplying terms in various orders using the associative property. Can you identify the benefits of choosing one strategy versus another? Well, multiplying the terms allows me to combine factors in more manageable ways, such as multiplying negative 2 times negative 5 to get positive 10, because multiplying other numbers by 10 is very easy. So what is the sign of the product and how is the sign determined? Well, the product is a positive value. Two negative values multiplied together yield a positive product. When a negative value is multiplied by a positive product, the sign of the product changes to negative again. When this negative product is multiplied by the last or fourth negative value, the sign of the product again changes to a positive. Alright, so let's do exercise 1 on the worksheet before continuing the lesson. Alright, for exercise 1, again, find an efficient strategy to evaluate the expression and complete the necessary work. So your method will vary. This is just one way to do it. But again, just so you can see what is going on, is associative property is when we multiply two terms together that are not in the order of operations. So here we're using associative property to get negative 4, and also 1 times negative 3, and then we use commutative property to switch these two terms around, and then multiplying the rest of the way through. So in your journal, what aspects of the expression did you consider when choosing a strategy for evaluating this expression? What is the sign of the product and how is the sign determined? And how else could we evaluate this problem? Well, is order of the operations an efficient way to multiply the expression below? Why or why not? Alright, let's take a look at exercises 2 through 4. Go ahead and complete these exercises on the worksheet before continuing the lesson. Here is exercise 2. Again, your method may vary. This is only just one example of how you could do this. But essentially what is happening is commutative property moving the negative 1/2 closer to the negative 8 because they're both negative, and this will produce a positive number when we multiply them. And again, moving the 1/3 next to the 9, because 9 and 3 have a common factor. So what ends up happening here is that 1/2 of 8 is 4, and again it becomes positive, and 1/3 of 9 becomes 3. So now essentially what we've done is turned some fractions into whole numbers based on just recognizing that 2 and 8 have a common factor and 9 and 3 have a common factor. Then we end up with 4 times 4 times 3. We know that 4 times 3 is 12 and 4 times 12 is 48. Alright, what terms did you combine first and why? Well, again, multiplying the negative 1/2 times 8 and the 1/3 times 9, because their products are integers and this eliminates the fractions. And here's exercise 4. Referring to the examples and exercises, do you see an easy way to determine the signs of the product first? And basically, if you count up the negatives, every time you have two negative terms, that's going to multiply to make a positive. So if you count up as many 2 terms as possible, you know that in this case you're going to have a positive 1, a positive 1, and a positive 1, which multiply together give you a positive 1. However, if you have an odd number of signs, you have even groupings 1, 2, and 3, but then you have this negative left over. So when you have positive 1 times negative 1, our answer is going to change to negative. Alright, going back to your journal, let's go ahead and do example 2. What is a mixed number? Well, a mixed number is the sum of a whole number and a fraction. What does the opposite of a mixed number look like? Well, the opposite of the sum is equal to the sum of the opposites. So for example 2, using the distributive property to multiply rational numbers, rewrite the mixed number as a sum, then multiply using the distributive property. So in this case, negative 6 times 5 1/3 would be written as negative 6 times 5 plus 1/3. So now distributing the negative 6, we multiply negative 6 times 5, and we're going to add it to negative 6 times 1/3. When we do that, negative 6 times 5 is negative 30, and again, because 6 and 3 have a common factor, negative 6 times 1/3 is negative 2. Then, combining those, we finish up with negative 32. So did the distributive property make this problem easier to evaluate, and how so? Okay, for exercise 5, go ahead and do exercise 5 on your worksheet, then continue the video. Alright, for exercise 5, using that same method, you could take negative 3 1/2 and turn it into negative 3 plus negative 1/2. Then by distributing the 9 times negative 3, and 9 times negative 1/2, we end up with negative 27 plus a negative 4 1/2. And easily we can put these together, because they're both negatives, to make negative 31 1/2. Alright, let's do example 3 on your worksheet. Example 3 says, using the distributive property to multiply rational numbers, evaluate using the distributive property. Well, we don't have any mixed numbers here, but we do have a common factor of 16. Again, this is 16 times negative 3/8, and this is 16 times 1/4, and they're being added together. So we can use the distributive property to actually factor out 16 and put it on the outside of the grouping of negative 3/8 plus 1/4. Then by using equivalent fractions, we can add negative 3/8 and positive 2/8 to get negative 1/8. And then last, we can just multiply that by 16, which will give us negative 2. So how is this expression different from the previous examples, and what can we do to make it more manageable? You want to make sure you write in the margin. This expression involves division by fractions, and we know that dividing by a number is equivalent to multiplying by its multiplicative inverse or reciprocal. So we can rewrite the entire expression as multiplication. All right, let's take a look at example 4 on the worksheet. Again, using the multiplicative inverse to rewrite division as multiplication, let's rewrite the expression only using multiplication and evaluate. So notice we have 1 divided by 2/3 and we have 3 divided by 1/2. Again, we don't want to have a division sign, so how can we rewrite this to use the multiplicative inverse? Well, this now becomes 1 times 3/2 times -8 times 3, and then times -2, because the inverse of -1/2 is -2. Now we can use commutative property to gather our like terms, moving the -2 next to the 3/2, because if you notice, they share a common factor of 2. And then we just move the 8 next to the 3. So now, -2 times 3/2 is -3, which now gives us all whole numbers. 1 times the -3 times the -8 times the times positive 3. Then combining 1 times -3 is -3. Moving the -3 and the positive 3 together. And then -9 times -8 is positive 72. All right, go ahead and try this on your own, exercise 6. Do this on the worksheet and then continue the video to check your answer. Okay, for exercise 6, turning our division problem into multiplication, we multiply by the inverse. Then we use commutative property to move the -10 next to the decimal so that this will turn into a whole number. And again, 1/3 of 6 can be easily, we can get rid of the fraction here to make 1/3 of 6, or actually, I'm sorry, they did this the other way. You could have done 1/3 of 6, but they decided to do 1/3 of 42, which is 14, which makes that positive, and then 14 times 6 is 84. You could have done -2 in this case. 1/3 of 6 is -2, and a -2 times -42 would give you 84 also. So again, these are just one, your answer may vary, this is just one example. All right, so how do we determine the signs of expressions that include several products and quotients? Name a property of operations and describe how it is helpful when multiplying and dividing rational numbers. While multiplying and dividing using strictly order of operations is not always efficient, the properties of multiplication allows us to manipulate expressions by rearranging and regrouping factors that are easier to compute. Where division is involved, we can easily rewrite division as multiplication to allow the use of these properties. The signs of expressions with products and quotients can easily be determined by checking whether the number of negative terms is even or odd. All right, we'll see you in class. Kind of already hinted at that. So the hint is up here. How did using the distributive property make this problem easier? And it's right about here. All right, so on your worksheet again, complete exercise 5 and then go ahead and continue the video to check your answer. So here is exercise 5. If we're going to use distributive property like it's asking us to, then we would break up the -3.5 into -3 and -1/2. Multiply each one by the term on the outside, which is 9, and we get -27. And in this case, it doesn't really get rid of our fraction, but it does at least give us a smaller fraction, then we can add these together. All right, example 3 on your worksheet. Evaluate using the distributive property again. Now, if you notice, you might be going, well, wait a minute, we don't have anything to break up. What we're using is kind of the reverse of the distributive property, and that means we have a factor that is common to both parts of this problem, and that is the 16. Both of these terms are being multiplied by 16, which means we can factor that out. So the 16 can multiply the negative 3/8 and the 1/4. So it's kind of, consider it pulling it out of the expression and then multiplying what's left. So it's still the distributive property, it's just backwards. All right, so in that case, we have these two fractions that we can add together, which means we have to get equivalent fractions. And negative 3/8 plus 2/8 is a negative 1/8, and then multiply 16. Remember, this is not 16 and a negative 1/8, this is 16 times a negative 1/8, and that is negative 2. So sometimes distributive property working it backwards will help us create an easier problem also. So how is this expression different from the previous examples, and what can we do to make it more manageable? So I gave you several examples and there are some labels there. What property did we use to make this problem a little bit easier to handle? And you can write that in the margin. So the expression involves division by fractions, and we know that dividing by a number is equivalent to multiplying by its multiplicative inverse or reciprocal. So we can rewrite the expression as multiplication. All right, example 4 on the worksheet. So using multiplicative inverse to rewrite the division as multiplication, we're going to rewrite the expression as only multiplication and evaluate. Interesting. We have 1 divided by 2/3. Well, instead of dividing by 2/3, let's multiply it by its reciprocal, which is what this is talking about. So the multiplicative inverse means that we're going to go 1 times, and we're multiplying by the reciprocal. And the same thing here, if we're dividing by a negative 1/2, well, the reciprocal of negative 1/2 is negative 2/1, and we can just drop the over 1 because it is a whole number. So now we need to move some things around to make an easier problem. And in this case, we're going to multiply 2 times 3/2 because what's going to cancel out here? Well, the 2's are going to cancel out and we're going to be left with a 3. So the associative property, once we put this together, is a negative 3. And we are multiplying it by 1, and we bring everything else down. And then the next thing we can do is 1 times a negative 3, because that's pretty easy, and then times a negative 8 and times 3. And then we can change these around, the 3 and the negative 8, so that the 3's are together. And then finish up by multiplying negative 3 times 3, which will give us a positive 72. Now again, going back up to the top here, how many negative signs are in this problem? Well, here's 1, here's another one. Well, that's 2, which is an even number. So we know that our answer is going to be positive. All right, go ahead and complete exercise 6 on your worksheet by yourself, and then continue the video. So again, your answer may vary as far as the steps that you are doing, but again, this is an example. So what they decided to do was to move the negative 10 and put it next to the decimal, because if you take 4.2 and multiply it by 10, that's going to give us an integer called negative 42. And then they put the fractions together, negative 1/3 and positive 1/6. And then they decided to do this because 42 is divisible by 3. So if I do 42 times 1/3, That's actually going to give me 14, and I'm sorry, that's negative times a negative, so positive 14. And then 14 times 1/6 is any of these numbers. So if you left it as 14/6, or 2 2/6, or 2 1/3. Any of those will work. And again, your process may vary, so just make sure you indicate what you're doing and show how you're simplifying, and of course label your steps. All right, so how do we determine the sign of expressions that include several products and quotients? That's one thing we did. Name a property of operations and describe how it's helpful when multiplying and dividing rational numbers. I'll give you a hint. It starts with a D. Multiplying and dividing using strictly order of operations is not always efficient. The properties of multiplication allow us to manipulate expressions by rearranging and regrouping factors that are easier to compute. Where division is involved, we can easily rewrite division as multiplication to allow the use of these properties. The signs of expressions with products and quotients can easily be determined by checking whether the number of negative terms is even or odd. All right, we'll see you in class.